Welcome to JD's Prep. So we have a diagram here representing Earth on the first day of a season. We've been asked, first off, to identify one possible date that is represented by the position of Earth in this diagram. We need to look here at the sun's rays and how they are hitting directly at the equator. We don't see a tilt of the northern hemisphere or the southern hemisphere towards the sun, which does mean that this is definitely an equinox. There are two possible dates that it could be, right? It could be the spring equinox or the autumn equinox, which is usually around March 21st or September 21st, in there around somewhere. Our next question asks us to compare the relative altitude of Polaris at location A and B. A and B are right there. So first off, the relative altitude of Polaris, is it higher or lower at location A than it is at location B? So A is closer to the equator, it's going to be lower, the altitude is going to be lower at location A, and the altitude of Polaris and the latitude of the observer are related, right? So the closer you are to the equator, the lower Polaris will be. So that would be your explanation. All right, and lastly, we're asked about time zones, essentially. We're asked to compare the solar time between C and D. So just a reminder that 360 degrees divided by 24 hours in a day, we have 15 degrees. Every 15 degrees is where we have a time zone change. So that's where you add an hour moving west. So if it is 6 a.m. here at C, then 30 degrees west is going to be 2 hours later, so it's going to be 8 a.m. All right, thank you for using JD's Prep.